Hi, everyone. It's great to be here with you this afternoon. My name is Nicholas de Monchaux, and I don't have a PhD. I'm not a scientist. I try to study things, but only in the means of trying to imagine how to design them in new and different ways. I'm an architect by training. I teach architecture and urban design here at Berkeley, and I'm chiefly interested in the way in which new thinking about water and infrastructure also generates very important new opportunities to think about the fabric of our cities. And in particular, much of my work in the last couple of years has been spent thinking and designing proposals around the idea that infrastructural resilience and infrastructural robustness, and those two concepts are slightly different, and I'll explain what I mean by them, with the way in which those things need to both allow, encourage, and make possible new kinds of economic and social and even cultural resilience and robustness too. Our cities are astonishing things that consist of physical systems, but also a million social connections, evenings spent at bars, street festivals, and they are creative economic and social engines that we need to both sustain and make even more creative through the work and design we do in them. The sort of slightly pedantic distinction I make actually between robustness and resilience is, I think, actually quite useful in this context. Resilience comes from the Latin word for bouncy, and resilience is like a ball bouncing back from being thrown down on the ground. It only gets back up to where it was before, and that's very, very important. But robustness is a concept that comes to us from the life sciences, and the robustness is technically speaking, it's the strength of a system, but what it really is, or the way in which it's used by evolutionary biologists, is the ability of a system to adapt to unforeseen circumstances, to new circumstances, to create out of change an opportunity and not just a negative component. So cities historically have been survived and thrived when they've been capable of making out of a shifting environment not just the ability to sustain themselves as they were before, as it were, but actually the ability to think inventively and differently about who and what they are. So the project that Jennifer introduced very ably, I almost don't need to give my lecture after her introduction, is called Local Code, and it started a couple of years ago. I was interested in the way in which within the culture of my discipline of architecture, computers are being used more than ever before, but mostly, almost exclusively being used to help us cope with the increased complexity that we've made for ourselves in the building system. It now, 40 or 50 years ago, Louis Kahn built the Salk Institute with 50 drawings. That's all it took him. And he was a very good architect and knew how to edit, but that was it. Nowadays, I think this, if you print out the buildings for this building that we're sitting in, which is a highly competent, wonderful building, you would get almost 2,500 pages of equivalent drawings. And so we have created our own technological complexity and generated a whole set of systems and tools, what we call building information management, to deal with that complexity. But my work is really chiefly to do with how we might kind of adopt and reappropriate some of the complexity of building information modeling and what's called parametric designs tools, and turn it to some of the really important complex problems that all of us are here to talk about today. So this kind of GIS analysis will not be novel to an audience like this one, but the kind of process of the design case studies that I'm going to show you is chiefly starts with the identification of what are actually many diffuse sites, and I'll go into that more in a minute, the kind of understanding of what all those sites are doing in the context of a larger city, an individual analysis of each site, a kind of localized design for specific sites contained within a framework of community engagement about a site and its future, and what you end up with is a whole host of design proposals for a kind of network infrastructure that turns out to have some very interesting properties, physically, socially, and infrastructurally. My own interest in this kind of work, and in particular in the use of underutilized and residual urban space, was sparked many years ago when I came across this piece of art by the architect turned artist Gordon Matta-Clark. It took him 7 years of looking through microfiche in New York City to find 7 abandoned sites that he appropriated and was intending to do a project for at the time of his death in 1978. Now, of course, we can find 5,000 to 7,000 residual public spaces in New York City. If we look at private spaces, it actually goes up to between 40 and 50,000 spaces. We can look at almost any American city. In fact, Jennifer herself did some groundbreaking work in this regard, looking at vacant and underutilized public land as a kind of seemingly immutable part of the public landscape of American cities. What I did with my students here at Berkeley, starting a couple of years ago, was start an examination of these sites in San Francisco. And in particular, we looked at about 2,000 sites, what the city calls unaccepted streets, which are zoned as rights-of-way but not used as rights-of-way. So this is even just a small subset of the larger system of vacant and residual land. And again, using pretty basic GIS analysis, we started to discover some very interesting things about it, which is true of larger studies of this kind of space in general. If you look at these sites in black, they seem to line up almost perfectly with a whole range of social and public health indicators in the city. They are, by nature, they're in low-lying places, they're in poor neighborhoods, and they also line up remarkably well with ecological issues like not only heat islands, but these are like known issues in the stormwater system with the presence of heavy and particulate matter in the city. And so the question then arises, what could one do with a kind of renovation of these sites? What impact would it be possible to have beyond each individual site, but on the fabric of the city as a whole? Our examination, and I'll present to you the kind of detailed design work of each of these sites, is not just a kind of speculation in design, but also a speculation in economics and finance. What if we took all the money that's being put, especially in a city like San Francisco, to expand underground sewer and water systems, and targeted at least some of these funds site by site to some of the city's most you missed the whole exciting animation. This is, of course, what architects can do. They don't have novel ideas, but they think in novel ways about how to present the information. And then what we did on each site to construct this larger design proposal was take a set of, again, pretty basic thermodynamic analyses, the wind speed across the site, the yearly sun exposure, the parts of the pavement and buildings that are most exposed to solar radiation, the speculation on how much stormwater could be captured on the site, and all of these combine into a kind of a single design proposal. Now this work, which as I say is, even though it's been going on for a couple of years, it's still very much in its infancy, also involves speculation. Here we did what is only a simulation with some of my colleagues at the Berkeley Center for New Media on how larger forms of digital and media infrastructure might be used to engage a public around manifold singular interventions in urban fabric, and then how we could, as is already the case with projects like Cyclic Fix and the work that's being done by groups like Code for America in San Francisco, how new thinking about physical infrastructure in the city could be tied into also new ideas about digital infrastructure and governance. And what you get at the end of it all is not just a party on the street, but also we imagined, certainly what we're trying to promote in the field of urban design and physical thinking about the cities is an idea about a network of spaces that is as resilient and robust at the many larger levels of the communities it serves as in the particular physical level of infrastructure, which we might imagine can help support its conception and creation. So In terms of what's literally produced out of this, again here, it's much as with the work that Christina showed. It's a speculation and a provocation. But here, using these same digital methods, which allow you to take a whole series of inputs, which are usually quite mundane in the context of a building information modeling system, we can also input environmental and financial variables. And so in this case, what we have modeled for each site is, on the one hand, both its both a kind of a speculation as to what the best selection of surfaces for the site would be, and then also given a rudimentary financial model and also the availability of various local grants depending on the site's location in the city, we kind of know how much money we could imagine spending on it, and those two things together actually result, along with a lot of other kind of iterative physical coding, in a specific design proposal for each site. I won't make you watch this whole movie because it's about 3 hours long, going through all 3,000 designs, but it was part of an exhibit on the project at SF MoMA last year, and I was told by the guard that at least one person did sit there because they apparently had a lot of time on their hands and didn't believe that we actually had as many designs as we said we did. So again, to take you through the process, this is true. This is San Francisco as a case study of something that we've seen can be the case in many different communities of residual and vacant spaces being focused in park-poor communities, in communities of color, in parts of the city with also with a particular, that represented a particularly important opportunity for environmental and infrastructural investment as well. This is the kind of individual, what we're able to do as far as actually coding not just a kind of generalized but very site-specific solution for each site. This is, again, the notion that each part of a public landscape can be seen as a piece of infrastructure as well, and should be. This is a kind of, as I say, our beginning speculation about how the essential step of community engagement can be a part of the process, and here again, the kind of multitude of results. I'll show briefly, of course, what is actually going on here is not the design work. The real kind of heavy lifting and what we've done with support from Autodesk, Citrus here on campus, and others is a kind of hacking process, re-engineering the new media of architecture, the digital tools with which design is based, so they can better accept information from large-scale, from software like a GIS, and that they can better output the results of their own physical output into a format that we can do the kind of large-scale validated modeling that we really need to make the case for this kind of work. And so to turn some of these digital tools into pieces of infrastructure themselves that are connected to each other in unexpected ways, and therefore by analog to create a system to better create the kinds of integrated systems that we need. The last project I'll show is a different kind of mode of work for us, but also very much, yeah, should be no problem. But also very much part of the history of sort of university nonprofit partnerships was a work that we were commissioned to do in Los Angeles with a group there called the Amigos de los Rios. They had a particular interest in sites like this one that large billboard companies like CBS Outdoor and Clear Channel lease or buy along freeways and major viaducts in Los Angeles that because there are a lot of eyeballs there. We actually, they had a map of about 100 sites they'd found on the ground. We were able to use a combination of Google Earth and the Amazon Mechanical Turk to expand that database to 800 sites by paying people 5 or 10 cents each to find one of these sites. And so we built this database for the nonprofit. Once we mapped the sites, we saw exactly the same kind of pattern of both of course, because of the freeways in LA were all built over culverted waterways to begin with, so these sites were particularly well positioned for stormwater retention and treatment, and then also well positioned in neighborhoods that didn't have access to parks. And so what we produced was a series of 800 speculative community space and park designs, not really green spaces, but spaces that could hold and filter water over time and form part of a distributed piece of infrastructure, and that also allowed the nonprofit, very crucially, to be able to go into neighborhoods and not just say, wouldn't you like to imagine a park here, but rather, wouldn't you like to imagine this park here, which is a very different question and a good example of the particular role that design can play in a process, even when it's not a physical thing in the ground. So I think I'll leave it there because I'm particularly interested in how we might open this to question and discussions between the multiple presentations. But thank you very much, and it's a pleasure to be with you.